So good evening all. Welcome to the next session for the evening session. Okay. Are you able to hear my voice? Right. Differential equations. Differential equations. Part 1. Differential equations part 1. Okay, thank you. Thank you. So first let us consider here let us consider y is equal to something e power ax. Just example. So differentiate both sides with respect to x. So if you differentiate both sides with respect to x, now what do you get? Dy by dx equals to d by dx of e power ax. We know e power ax differentiation is e power ax, then multiplied by a, you will get it now. So equation 1. Now from 1, so we can write this equation as ay. So this is equal to, we get an equation dy by dx minus ay is equal to 0, or we can write this one is equal to y dash minus ay is equal to 0, or we can write y1 minus ay is equal to 0. So now this kind of equation is formed with the help of this y is equal to e power ax. So understood now. Okay, Pushpa, first subscribe. First you need to subscribe. Right, next. So let us consider one more example. Let us consider x square plus y square equals to a square. This is the equation of the circle whose center is at origin, having a is the, okay, I received Nagesh. Okay, I received. Thank you. So now differentiate both sides with respect to x. Differentiate both sides with respect to x. So now what do you get now? 2x plus 2y. Y differentiation is 2y by dy by dx. A square differentiation constant 0. So divide both sides by 2. Divide both sides by 2. Now we get x plus y dy by dx equals to 0. This we can write like this: y dy by dx plus x equals to 0, or we can write y dash plus x is equal to 0, or we can write y1 plus x equal to 0. So actually this is the equation is consisting of the differential coefficients. Okay, differential coefficients. Actually here x is called independent variable, y is called dependent variable. So an equation which is consisting of differential coefficients and independent variable and dependent variable, that equation is called as differential equations. So this is one of the example for a differential equation. This is called differential equation. and this is also called example for differential equation. So now let us consider one more example. Here see, let us consider so one of the examples, y equals to, sorry, 1 minute, may not be 1, you can take no problem. X is equal to a sine omega t plus alpha. Say this is equation 1. You consider this equation now. X is equal to a sine omega t plus alpha. Here t is the variable here, and next differentiate with respect to t, because t is the variable here. So dx by dt equals to, we get a times sine differentiation is cos omega t plus alpha. Next omega t plus alpha differentiation is omega alpha differentiation 1. Say this is 2. Again differentiate it. Differentiate with respect to x. Now what do you get now? D by dx of dx by dt equals to a times d by dx of cos omega t plus alpha into here a omega. So this we can write d2x by dt square, d2x by dt square a omega into minus sine omega t plus alpha, because cos differentiation is minus, into omega. So now this equals to, we get minus omega square a times sine omega t plus alpha, you can write. See, a sine omega t plus alpha is equal to x. In the place of this we can replace x. So we get this is equal to minus omega square x. So that means we get an equation d2x upon dt square plus omega square x equal to 0. This is also called differential equation. So this d2x by dt square, actually here see, d2x by dt square is proportional to x. That means acceleration is proportional to the displacement. This happens only in simple harmonic motion. You have discussed in SHM physics, simple harmonic motion. Understood now? This is also called differential equation. But in the previous differential equations, this differential equations, what is the change now? So indefinite integration is completed, that is indefinite completed, definite completed, right? So now, so these are the types of the differential equations. So now let us consider one more example. Let us consider. See, let us consider some f is equal to, I write like this, ax square plus by square. Okay, Nagesh. Say equation 1. Dou f by dou x you find out. What is dou f by dou x? So dou f by dou x is equal to, you get 2ax plus 0. 2ax you will be getting. Find second derivative. Dou 2f by dou x square. Here 2a. Again you find differentiated. Dou 3f by dou x cube is equal to 0. Say equation 2. Similarly, if you differentiate with respect to y also, dou 3f by dou x cube is also 0. Adding 2 and 3, you get dou 3f dou x cube plus dou 3f dou y cube is equal to 0. Here we get equation in partial derivatives. So that means now differential equations can be classified into two types. One is ordinary differential equations. Second is partial differential equations. But our discussion is only up to limited to the ordinary differential equations itself only. So that means ordinary differential equation example we can write like this. Just now we have discussed C x dy by dx plus y equals to 0. Another example we discuss d2x by dt square plus omega square x equals to 0. And next dy by dx whole square minus 3 dy by dx plus phi equals to 0. So that means in ordinary differential equations, you remember just ordinary differential coefficients will present dy by dx. Even sometimes see dy by dx, that means we can say y dash, y double dash, y triple dash also may present. But here partial differentiations. Generally the partial differentiation x dou f by dou x plus y dou f by dou y equal to something n f. Second x square dou 2f by dou x square plus 2xy dou y dou 2y by dou x dou y plus dou 2y square dou 2y by dou y square equals to 0. So these are all called partial differential equations. So generally we have the actually now the most important point. Now we deal in this chapter ordinary differential equations itself only. In first concept we have order, that is very important. So let us discuss about the here onwards. This is very important. Order. What is the order of the differential equation? Order of the differential equations means the order of the highest differential coefficient present in the differential equation is called order of the differential equation. So for example, see what is the order means. Here you can write like this: the order of the differential equation is the order of the highest order derivative or differential coefficient present or occurring in the equation. So that means, for example, see, this is dny by dx to the power of n is there. This is called nth order differential coefficient. In the similar manner, you can say d2y by dx square. This is second order differential coefficient. So one example let me discuss. What is the example? The order of the order of x dy by dx plus y equals to 0. You check it here. Here dy by dx only one differential coefficient present. So that means derivative. Derivative is dy by dx. What is the order? We are saying only 1. That means is 1. For example, the order of x d2 y by dx square minus 2 dy by dx plus 5y equal to 0, for example. In this, what is the highest order derivative? This you need to check. Highest order derivative is this one. Highest order derivative is the d2y by dx square. What we are saying? 2 d2 means this order is 2. We need to write order is 2. Next we need to discuss now degree. That is very important. Degree we need to remember. We need to discuss. Next, degree of the differential equation. Degree. What is the degree? The degree of the differential equation is the highest power of the sorry 1 minute, is the power of the highest derivative involved in the differential equation. But one thing you need to keep in this one is when equation has been expressed in the form of a polynomial by eliminating radicals. Radicals means fractional powers. Radicals are fractional powers of the derivatives. So this seems to be very lengthy. Don't worry, the degree very easy to find out. So that means the degree of the differential equation is the power of the highest derivative involved in the differential equation. But one thing you need to keep up. This point is very important. This point, when equation has been expressed in the form of a polynomial by eliminating the radicals or fractional powers of the derivatives, then that is called the degree of the differential equation. So now let us go for examples now. Here see, example you consider. First example, here d2y by dx square whole cube minus 4x dy by dx plus 5y equals to 0. This is ordinary differential equation. Okay, we can, just like in organic chemistry, we can name the differential equation also. This differential equation we can call as This is ordinary differential equation, ODE. This is called ODE, ordinary differential equation. Now we need to tell for this one is degree. First order we can give order. Next degree we can discuss. Degree we can discuss. Degree. First check in this equation. Here what is the highest derivative differential coefficient, that is d2y by dx square. Order is 2. What is degree? Degree is the power of the highest order derivative present in the involving the equation. Now dy by dx is only 1, order is 1. Here d2y by dx square is the highest. What is the power we have? 3. So degree is equal to 3. So this is called actually second order, third degree ordinary differential equation. We can name the differential equation also. The differential equation will be named by its order and by its degree. So and its nature also. So second order, third degree ordinary differential equation. This is called. For example, we go to another example. So you consider another example. See, dy by dx whole to the power of 1 by 3 equal to d2y by dx square whole to the power of 1 by 2. See, now you check this one now. This is basically, this is called what? This is called ordinary differential equation. Okay, this is the first point. We know this ordinary differential equation. Okay, so now dy by dx whole to the power of 1 by 3, d2y by dx square whole to the power of 1 by 3. Here we can write order very easily. Order equals to this one, d2y by dx square. Second order we can write degree. Degree is very important. But degree, what is the definition of the degree? What is the definition of the degree? See, what is the definition of the degree? The degree of the differential equation is the power of the highest derivative. Power of the highest derivative involved in the differential equation when the equation has been expressed in the form of a polynomial by eliminating radicals or fractional powers of the derivatives. So we should not consider fractional powers. So that means actually here, see, we have fractional powers. That means we need to take LCM of 2 and 3. What is the LCM of 2 and 3? That is 6. So both sides raise the powers to 6. 1 by 3 into 6, that means square, dy by dx whole square. Now it is free from the radicals, fractional powers, d2y by dx whole cube. Now see, this is the highest, differential derivative. Power is 3. So degree is actually 3. Degree is 3. So what? How do you name it now? So it can be named as second order, third degree ordinary differential equation. Second order, that's next second order, third degree differential equation we can. Okay, this is called second order, third degree ordinary differential equation, ODE. This we can name like this. Okay, now formation of the differential equation. Formation of the differential equation. Formation of the differential equation. How to form the differential equation? Okay, we're not Ram. Okay, right. How to form the differential equation? See, for example, if an equation f of x comma y, this is independent variable, dependent variable, this is c1, c2, c3 and so on, we have cn equals to 0. We have 1, 2, 3 up to n constants we have. Right. Has n arbitrary constants. N arbitrary constants. This C1, C2, C3 and so on, Cn are called arbitrary constants or parameters also. So then differentiating n times successively with respect to x and eliminate arbitrary constants, we get differential equation. That is in the form of, generally you say capital F of, it is also function of x comma y, y dash dy by dx, y double dash, y triple dash or y 4 and so on, see y4 dash and so on, yn nth derivative equals to 0 you will be getting. That means actually here we get nth order differential equation, will get it. Because if any equation contains n arbitrary constants, after forming the differential equation, we can say that its order will be n itself only. The order of the differential equation is equal to the number of arbitrary constants present in the given equation. Okay, right. The number of constants is equal to order of the differential equations. Right. Important point. The number of arbitrary constants in the general solution of the differential equation is equal to the order of the differential equation. That means, for example, it has n arbitrary constant, means n times we need to differentiate it to eliminate them. Right. Okay. Right. So next, solution of the differential equation. What do you mean by solution of the differential equation? Solution of the differential equation. This is very, very important. How to find out the solution of the differential equation? We will form the differential equation. Okay. Next, we need to solve it. How to solve it? For example, see, you consider, first let us frame, let us say y is equal to mx. What is dy by dx? Is m. Substitute m in the equation 1. So we get the differential equation is x into dy by dx equals to y. Now how many number of constants are there here? Arbitrary constant, only one. That's why actually order is 1. X dy by dx is equal to y is the differential equation. Now we need to get the solution back. How to get the solution back now? So let us see now. Here we know the differential equation, that is x dy by dx equal to y. Okay, this we can write like this. Dy by y equals to, we can write dx by x. Integrating on both sides. Integrating on both sides. Integrating on both sides. Just integrate it. Just integrate it. Right. So now integrating dy by y equal to dx by x. This is log y equal to, we have log x plus log c right down. So this we can write log cx, but you won't get m, but no problem. Now y is equal to cx, or generally in the place of c replace m. Y is equal to mx is the solution of this differential equation. This differential equations. Okay, no problem. Even no problem. Right. Better to leave. Right. Understood now. But we won't get exactly that arbitrary constant. Any arbitrary constant may come. That may be in the form of y is equal to mx itself only. So that's why we can form the differential equation and we can solve the differential equation. Understood now, simultaneously. So now this y is equal to mx is the solution of this differential equation. See how, see here, if you differentiate again, you get this equation. So y is equal to mx is called solution of the differential equation. So next we shall discuss methods of solving first order and first degree differential equations. First, let us concentrate in this. At this level, we have how to solve the differential equations whose order is 1 and whose degree is 1. First order and first degree differential equations. So the first method we have variables separable. In the previous case I have done variable separable itself only. Okay. Right. If a differential equation can be expressed in the form of dy by dx equals to f of x by g of y, or f of x dx equal to g of y dy. Then it is said to be variable separable. So variable and separable. So how to solve this equation? Very simple. So if you integrate this one both sides, you get the answer. So that means this can be solved. F of x dx equals to g of y dy. Integrating both sides. So we get integral f of x dx plus integral g of y dy plus constant of integration. This is the solution of the differential equation. We can solve in this way, variable separable. Okay, this is also maybe homogeneous, may not be homogeneous, we do not know. But next is homogeneous equation. Second one is homogeneous equations. Homogeneous equations. Okay, I will explain once again. Homogeneous equation means if the given differential equation is in the form of dy by dx equals to f of x comma y, function of two variables x comma y, right, upon g of x comma y. Both are functions of x comma y. Here where f and g are homogeneous function. homogeneous functions. Homogeneous functions. So homogeneous functions in x comma y of same degree or equal degrees, we can say that. Then this equation is called, okay, homogeneous differential equation. Homogeneous differential equation. Example, we can write dy by dx equals to x plus y by x minus y. This is one of the examples for homogeneous differential equations. Homogeneous differential equations. Understood now? So how to solve, I will explain actually here while solving the problems. Okay. Next one is, third point is non-homogeneous equation. Non-homogeneous equation. Non-homogeneous differential equation. Okay. If the equation of the form dy by dx equals to a1x plus b1y plus c1 upon a2x plus b2y plus c2, where a1 comma b1 comma c1 and a2 b2 c2 are constants, not arbitrary, just simple constants. Okay, then it is called non-homogeneous equation. Non-homogeneous equation. Non-homogeneous equation. Non-homogeneous equation. Okay, now in that also we have how many types? Actually 3 types we have. Here 3 cases we have in this one. So that we need to discuss. In 3 cases we have. So now there are 3 cases. There are 3 cases. Case 1. Case 1 is if a1 by a2 does not equal to b1 by b2. So now a1 by a2 does not equal to b1 by b2, then put small x is equal to capital X plus h and small y is equal to capital Y plus k. It becomes homogeneous, then we can solve it. Y is equal to capital plus yk. Then d capital Y by dx becomes a1 capital X plus b1 capital Y upon a2 capital X plus b2 capital Y. This is homogeneous. Easily we can solve it now. Understood now? So next case. Hence, it can be solved. It can be solved. After that, capital X is equal to small x minus h, we can replace. Last, here capital Y is equal to small y minus k will be replaced. Okay, next case 2. Case 2. Case 2. What is case 2? If A1 by A2 equal to B1 by B2, then your substitution, put A1x plus B1y equal to something t, and then solve the equation using variable separable only, using variable separable itself only. Next we have case 3. Case 3. Case 3. Case 3 means regrouping. Regrouping. That is actually we can solve now. If A2 plus B1 equals to 0, if A2 plus B1 equals to 0, then the solution, then it can be solved. It can be solved. It can be solved by proper grouping the terms. Grouping the terms. That means you remember A1 by A2. A1 by A2 does not equal to B1 by B2, one condition. A1 by A2 equal to B1 by B2. So other condition is A2 B1 is equal to 0. Then we need to proper grouping. Then we need to integrate it. We get the answer. That will be easy method. So next one is very important. We need to discuss. Next form is linear differential equation. 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 See, a differential equation of the form dy by dx plus p of x of y. P of x is the function of x. P of x is the function of x. P of x is equal to y equal to q of x. Q of x also function of x. Or even reverse also we can take. A differential equation of the form dx by dy plus p of yx equal to q of y. That is also linear differential equation itself only. Linear differential equation itself only. So that means is called linear differential equation. Linear differential equation of first degree or first order, of first order, because in degree we have second order also, third order also, nth order, but here we have only up to first order, restricted to first order. First order in y, where p of x and q of x are functions of x. Sometimes they may be constant. functions of x are constants. So now, so this is the actually how to solve this one. How to solve this one? How to solve linear differential equation in X. Okay. First step 1. What we need to do? Step 1. First we need to find out actually here integrating factor. Shortly we can write IF. IF is equal to e to the power of integral p dx. P is the function of x or constant also. So that is IF. Step 2. Step 2 is solution is y into integrating factor equal to integral q into IF integrating factor dx plus constant of integration. Very simple way we can solve linear differential equation in X. But generally in the examination you may be asked to write, even it may be Ecet examination or any competitive entrance examination, you may be asked to find out integrating factor. That's all. Integrating factor means e to the power of integral p dx itself only. Sometimes you may be asked the solution also. Don't get any confusion. So next now, next point. If the differential equation is of the form dx by dy plus p of y x equal to q of y is called linear differential equation in y. Here solution is like this: x into if equal to integral q into if dy plus c. Here if is equal to integral p dy. Instead of that we need to write here. So here if equals to e power integral p dy. You remember this. Okay. Simultaneously we have discussed linear differential equation in X and linear differential equation in Y also. So next one is Bernoulli's equation. Bernoulli's equation. Okay. An equation of the form dy by dx plus p of x to y equals to q of x into y to the power of something, y to the power of n, where p of x and q of x are the functions of x, then it is called Bernoulli's equation. Bernoulli's equation. It is called Bernoulli equation. So now how can it be solved? How can it be solved means simply remember, divide both sides by this y to the power of n. So dividing both sides by y to the power of n. Next we need to then this can be converted into, above equation can be converted into this form. So dv by dx equals to plus 1 minus n times pv equal to 1 minus n times q. Again linear differential equation it becomes, then we need to solve it now. Understood now? So it may not be asked in the examination, this may be, but just simply remember what is the Bernoulli's equation. Understood now? Variable separable, next homogeneous equations, next non-homogeneous equations, next we have linear differential equations in two types, next Bernoulli equations. Sometimes by inspection also you may be asked. By inspection, let us see. By inspection, see, integrating factors, IFs from inspection. Just by seeing only we can say the integrating factors by observation. See, first one, simply you find d by dx of x plus y. What do you get now? Differentiation of x is 1, derivative of y is dy by dx. Multiply both sides with dx. So that means d of x plus y equals to dx plus dy. Now you remember one thing. Integral of dx plus dy is nothing but x plus y. That's all answer. So next, second one. Now d by dx of xy, find out. What do you get now? D by dx of xy is UYV method, y square, y into x differentiation 1 minus x into dy by dx. Now multiply dx on both sides. D of x by y equals to here y dx minus x dy upon y square. See, wherever y dx minus x dy by y square is there, you can replace d of xy. If you integrate, you get x by y only. In the similar manner, d by dx of y by x, you find out. What do you get? D by dx of y upon x, that is x square, x into y differentiation is dy by dx minus y into x differentiation 1. That implies d of y by x equals to x dy minus y dx by x square. Actually these are called integrating factors with inspection, by inspection. Okay, by inspection. So multiplying dx, y dx cancel, dy by y square. Multiply dx cancel, d of y by x, dx cancel, x dy, y dx by x square. Okay, you can leave, no problem. Fourth, d by dx of log xy. See, this we can write d by dx of log x plus log y. What is the derivative of log x? You can write 1 by x plus 1 by y dy by dx. Okay. Now cross multiply. If you cross multiply, what do you get now here? D of log of xy equal to dx by x plus dy by y, or we can write like this: x dy plus y dx upon xy. That can be replaced by log of xy. Okay. Next, fifth point. D by dx of log of x by y. Log of x by y, or y by x, you can say, no problem. Y by x, y upon x. This is log y differentiation is 1 by y dy by dx minus log x differentiation is 1 by x. So therefore d of log of y by x equals to dy by y minus dx by x. This can be written x dy minus y dx upon xy. So similarly, you can generate so many. You will generate so many integrating factors like this. One of the examples I have given. Okay, now see, I don't give any today onwards give the notifications to you. Please you need to check, because we have the regular viewers. Once again, that's why you need to stay up to till the completion of the class itself also. But because of your low charge, you are not able to continue the classes. So don't worry. So tomorrow I'll give the notification. So before conduct the class, even if I give the 1 hour also, what will happen means some miscreants are entering in our classes. They are disturbing us. So they are distracting our classes. Lot of disturbance is coming. That's why I stopped the notifications. Understood now? Okay. But moreover, tentatively classes will be like this only. Don't worry. In the morning, I'll tell in between 9 o'clock to 11:20 like that. In the evening session, 4 o'clock to 5:30. That's all. You remember timings. Okay. So tomorrow onwards, I don't give any notification. Please, you need to be ready itself. That's left to you. Thank you. Bye bye. See you.